Hey, how's it going? So this is going to be a live stream recap. Yesterday on the live stream, which was extremely long, we took apart, I believe it's called the seatback hub on the permobil power platform chairs. This is a connection block on the back of the chair that connects the power platform system to some of the ICS components and a few other things. But these, I believe, may be causing some of the bad cable errors that people are getting after a firmware update. A number of users have told me, and actually the one this came from, after this was replaced, their bad cable error went away. So we're going to tear into this thing and see if we can actually figure out what's going on. The live stream was super long. This video is probably about 25 minutes long and gets a little bit more directly to the point. So anyways, hopefully you enjoy. Let's take a look at what we did yesterday over 3 hours. Hey, how's it going? It's going to be a little tricky because sometimes it's loosely connected things and the process of taking stuff apart might fix it. What I'm hoping to see, in the sense of, aha, there's your problem, is like some cold solders or something that's not connected properly or something like that. But anyways, here is the thing in question though. Hang on, does it say what it is? Do not open, no serviceable parts inside. There's a screw here and one under the sticker. Made in England. Permobil part number 336154. Well, we're about to service the parts inside, whether it likes it or not. Let's get this brand new motor put back together here real quick, so we can get it off the bench. Maybe there was a bad batch of these connection blocks. Yeah, it could be. It'd be kind of funny if it was actually a hardware error that didn't show up until the firmware update happened for whatever reason. There we go. It's a thing. So, let's do some zooming action here. So we've got what appears to be a Torx bit of some kind. Maybe a security Torx. Nope, just a Torx. Boy, we've got stacked things in here. No weather sealing here, which we shouldn't normally need. It is mounted in an orientation like this, and this part, I believe, is kind of clipped into something. But we've got... let's get in closer here. We've got some right-angle boards soldered on here. I can't tell if that's screening or some sort of antenna. I think that might be ground plane screening. Here, we need to get on the crossword puzzle glasses here. Sorry, it's going to be out of focus for you for a second. Oh, those are some pretty high current connectors. Look at these guys. They're, I don't know, that's not really coming through on camera. There we go. You can see, those are like semicircular, high current looking thingies. Do we have to ban people just for fun? So these all appear, there's a crap load of flux everywhere. And what appears to be a semi-feeble attempt. Well, if that's conformal coating, it's literally just chipping off. Maybe that's just flux or really bad conformal coating, but I just barely touch it with my tweezers and it turns to dust. So that's interesting. I get the feeling that's just flux because it's kind of splattered all over the place. Then we have a, hang on here. We have a board interconnect here that looks like a slightly questionable connection, perhaps. But let's see if we can figure out how to get this thing out of here without explodiating it. Replacing this fixed the bad cable error on the particular chair it came out of. These pins appear to be pressed through the housing, which seems to be all one piece. It looks like there, at least on these ones, it looks like there may be a gap that we can slide them out. So it appears as though the pins, the frictal forces of the pins and these standoffs are the only thing holding this in here. Perhaps. So the question is, can we make it not be in here anymore? Careful prying, maybe. Oh boy. Huh. Unless this was all molded together after those are put in there and the pins are actually molded in place. That would kind of suck. This thing moves a little bit when I press on it. I wonder if we have to desolder all this. That might be the case, actually. Oh, wait, here. Let's see if we can be sneaky and figure this out. I'm going to look and see if there is splattering of flux on the inside of the plastic case. There is. This was soldered after it was put together. So I think the pins are in fact molded in here. But yeah, I can see splattering of flux all over the inside of this. So we have to desolder this. We do have labels though, which is kind of cool. 0 volt line in, 24 volts switched, V battery, data, 0 volt, 24 volt. Cut the plastic away. Yeah, I mean, I don't think that would work necessarily well. I mean, we could, but see, the problem is here now we're desoldering, so we may already be fixing whatever problems it had that were causing the bad connection. But yeah, after looking at it now, this was soldered together after it was put into this case, and I believe the pins are molded into the plastic there. So let's see if we can do something here at least. I think there's just too much metal here for anything I've got. Yeah, it's just making stuff stick. Okay, well anyways, time for a more destructive route. Let's see. This feels kind of fiberglassy. PBT. What is PBT? Polybutyl something? Curtis Wright. Something something. Well, these were really cheap and they're really sharp, so let's see if we can nibble our way in. Who needs to grind down the plastic when you can just melt it off? Yeah, I thought about the slamming method, but these posts are just too big. I don't own any Dremels either. The only thing I have is that giant oscillating multi-tool. Wait, is this susceptible to this? Oh, it totally is. Okay, I can work with this. I feel like I should have safety glasses on. Oh yeah, this will totally work. Alright. Good call, whoever said to just go in mechanically. It sure feels like glass fiber, but it also doesn't at the same time. Yeah, okay, now you can see. Check it out. See where this connector is butted right up to the board? The pins are molded into this plastic and then they soldered them on. So that's why they're not sliding out. That's my story and I'm sticking to it. Yeah, the buzzy cutter's a little too unwieldy though, and the blade's as wide as the whole thing. What we need is the vice of knowledge. They definitely don't want you poking around in that box, yeah. Look at that. Our little hack with the knife actually worked. So, luckily, all the circuitry's on the inside. Oh, we do have some crappy solder joints here, though. Oh, we have another board-to-board interconnect, and there are some very sus solder joints. Yeah, these solder joints do not look proper. So we've got an interconnect that goes from here to here. And yeah, that's all it does. And we have some power conversion circuitry down in there. But yeah, that does not look super proper. But I would say that between this connector and this one here, there's enough weirdness in those solder joints to make me think that they could be partially to blame with this. What am I looking at? This is part of a chair that failed on a power platform chair that caused bad cable errors. Yeah, I'm going to go ahead and say that our... Yeah, look at these. Our board-to-board interconnects here. Those are some pretty crappy solder joints. Look at that. So they put this thing together, and then they clipped off and or soldered in some order these things. It looks like they soldered them and then clipped them. Oh, gross. Look at that. That is a bad solder joint. So yeah, I'm going to just go ahead and say that the board-to-board interconnects on this thing are the problem. Let me get a picture of this other connector on the other side here. They don't remind me of the best, especially that one right there. Look at that. Right here by my thumb. That is not a good connection. The rest of these are kind of cold solders, but they're probably okay. And then that one right there also. And that's on the other side. This side's independent. So, yeah, I'm just going to go ahead and say that our board-to-board interconnects are the problem on this thing. And I think what happened was they stack this stuff together, then solder it, and then clip the things off. And I think having those extra leads on there when they solder them wicks away enough heat that they weren't getting enough heat into those to solder them properly. These ones here looked kind of crappy in that photo because they're the ones I messed with, but the big solder joints are electrically connected pretty well. But yeah, I'm going to go ahead and say that's our issue, especially on a CAN network. There we go. See that third pin? You can see half the pad doesn't even have solder on it. So yeah, ignore this stuff up here. But yeah, I think that's solid enough to say that's probably, I mean, it's not a 1000%, well, there's your problem, but it's definitely, are you sure you want to release it to the customer that way sort of problem, if you understand the difference between those two. Like, it might be okay, but come on, really? Are we going to send it, like that? You know? And that's without going even deeper in here. Yeah, and this is all definitely handwork to get this thing together the way it's built. So we've got all of our pins are molded in. Let me see if I can get a picture of that. Our pins are molded into the plastic. They put the board on, solder those on, and then drop the other board on top of that and solder those in. So these pins, you can see, are directly molded into that casing. They're, you can tell the way the plastic kind of retracts around the edge. And even the way it dried, it's kind of like, I don't think you can see it, but it's kind of cracked there a little bit. Yeah. All right, well, this comes, see, when you're building products, there's a few stages. There's the actual, oh no, I'm getting burned. There's the actual designing of the product to make sure it works, proof of concept. Then a few steps down the road, you have to go into prototype manufacturing, where you figure out a way to actually build the thing reliably. And I think that's where they were just kind of putting this stuff together by hand and didn't quite figure that out. And a lot of times when you get to that point, I'd be curious to look at a newer one, but a lot of times when you get to that point in manufacturing, you can put a few of them together and maybe have some problems and be like, all right, well, cliche, we need to go back to the drawing board. Instead of having these right angle solder pins, because these are just 90-degree pins that they put in here and then through here, they might need to go back to the design and say, hey, we need to put a connector on there so they can actually snap the thing in, you know? But seeing as how the case is holding this all together and they're kind of relying on this to hold these pieces flush, then you might have to, say, redesign the casing to add some screws to hold that in. You really shouldn't be relying on solder joints to stabilize things anyways, but it can get very expensive and go back and forth and, you know, take a lot of time. But this board is literally being held in by those solder connections. There's no other mechanical attachments anywhere on this. Yeah, it's just held in with that. So, rush to production, get it out the door. This is why when you take apart stuff, you'll see revision B, revision C. And I don't see any revision numbers on this, unless it's baked into the code itself. And the other thing, too, is sometimes when you're building stuff, you're working with different suppliers. So then it's even more tricky to go back and say, hey, we need this part to be different. But yeah, I'm gonna go with that. Any thoughts? I think permobil might like to see that for R&D. Yeah, that's why I'm not gonna take this stuff apart. I'm gonna get some better photos of this and actually show what's going on there. But it's, again, it's one of those things. It's not a aha, there's your problem. It's just kind of like, we really need to fix that before we do any more troubleshooting sort of level of problem, you know? You can't rule that out. And really wouldn't, yeah. I don't even know what the back of it looks like. I would like to take this off and see, because I can kind of see some, like they're using 90-degree pins in there. I'd like to see that a little bit. Oh, wait, we can. I forgot. I have things for this. We have a little camera we can shove down in there. We have some fairly densely populated boards. It's like some sort of futuristic city in here. Oh. I think that's it right there. Can we get a better angle on that? This inductor's in the way. Okay, that should be enough. Let's plug this hoopty into the computer and take a look at those. There we go. Yeah, it's right. Whoops. Okay, infrared view. I want to zoom. These are those board-to-board interconnects they're using. So I would think replacing that with a connector would be a lot better. Is that broken? Yeah, I think that's just a light reflection. I think we need to go back into this thing. I mean, it could just be very well the light is being weird. But, yeah, you can kind of see there. We don't have the most resolution in the world here, but it wouldn't make sense that those would be broken, though. It just, I think it might be an optical conclusion. But, again, looking at that, it looks like there's nothing there. Maybe we can use the other camera on this thing to see a little bit better. Yeah, let's get this part off of here. And we should be able to see in there a little bit better. All right, the dissection continues. I've seen those seat hubs cause bad cable layers. Yeah, I think that's what's going on with a lot of the power platform chairs. And if you just came in, what we determined, I think, was we have some pretty bad solder connections here. And they really should have used a connector, and this whole board is hanging off of that. And the way this is set up, it looks like it was hand soldered together, which is normally fine, but they need to figure out a different way for building these things and making them more robust, out of a lack of better word. Hang on, I can't say that word without pressing the button.
Robust.
What do you think, Beavis and or Butthead? I concur. All right, let's see if we can get the other half of this thing off of here now. You get a nice corner here to work with. You're supposed to cut towards yourself with a sharp, jerky motion, right? Oh no, it was lift with your back with a sharp twisting motion. That was it. Yes, they are crappy. There's an update on permobil can force resolve intermittent cable layers, but only intermittent. It's data reissuing and software. So what happened was a firmware update at some point after the chairs were pushed out made the bad cable error happen. So I'm assuming in the software they adjusted their tolerances for what a bad cable error is, but that went below the threshold for the actual hardware connections. You can see on this one we have exposed pad right there as well. So, like I said, it's not a smoking gun, but it's definitely enough to be like, we must fix before we continue troubleshooting. Let's see if we can get this to do something that doesn't explode in my eye. Yeah, that thing's just flopping in the breeze. And actually, it's resting on top of some of the components down in there, too. Good times. All right, let's see. How do we want to bias the force? I think this way. The resistance tolerance for those has to be very tight because of the nature of the application. Yeah. Hey! All right. Now, let's see if there's any wires actually missing, or I'm just... oh, our thing's still plugged into the computer. I'm sure it was an optical illusion, but... Sorry, optical conclusion. That's like neodymium. I have to program the rest of the world to use terms incorrectly. But I'm sure it was an optical conclusion. So we need to figure out for sure. Can this thing see around corners? Not very well. Luckily, our board's not mounted on anything, so we can just kind of... Ooh. Is that... Hang on. Looks like there's corrosion in there. Oh, that is just completely clean solder pads. Oh! They... Let me show you how they put this together. Where's the thing I just had a minute ago? This is exactly the parts they used, and exactly, well, maybe not exactly, but the method they used to make this happen. Okay. Pin headers, right? This is what's soldered into the board on that thing. What they did was this, and then soldered them together. So there's a row of pin headers in there. They just bent them and then soldered them in place. Obviously, being a double-sided board, you can't get the solder on the backside, but you're relying heavily on the vias on this thing, which... Yeah, they're relying on the plated through holes to be in perfect shape on this circuit board. The backside of this, where all the electrical... Sorry, I'm getting excited. The backside of this, where all of the electrical connections are to the traces, is where everything goes. But they've only soldered the backside of the board, and none of the solder really got through. I'm going to see if I can get a picture of it. So we've got pads in there with no solder on them, which, in a perfect world... If all of your plated through holes are fine, sure, but plated through holes are not perfect. Or anywhere close to it. I need more hands. There we go. Can you see that on the camera right there? That is a pad with zero solder on it. And all the traces connect to it. So, yeah. I'm leaning more and more towards now saying that, yeah, we know what our problem is. What is the focus range on this thing? And yeah, there's an inductor down there that is being pressed hard against the case on this too. And a bunch of these capacitors and stuff as well are just resting on the plastic. I mean, they do appear to be gold-plated pins, so I guess that's something, but like, I don't know. Yeah, it's a little hard to tell what you're looking at, but yeah, so there's our pin header, and just the pins are bent. Like, you can buy these, where'd it go? You can buy pin headers with a, you know, 90-degree bend in them already, but anyways. Hey, there we go. Look at that. So, hang on, are these... There we go. So there's our pin header. It is at least appear to be gold-plated, maybe. That's not even bent 90 degrees. That looks manually bent to my eye. And you can see our pads here that actually go off and connect to stuff. And there's no solder here, so I don't know how... Again, if you've done any sort of PCB work, you know that plated through holes are not the most reliable thing in the world. Like, they're cool and all, but like, yeah, you don't want to rely on that for your good connections. There you can see the pin headers. But yeah, I believe that's our smoking gun right there. They didn't spend enough time prototyping their manufacturing. I don't think they dipped the pins in flux to get it to flow up. Yeah, and here's the thing, like, these pins are way smaller than they look in the photos. These are ridiculously tiny. But
it looks like what they did was they pushed them through, they melted some solder on, which having the extra length of pins sticking through means it's going to require more heat, and maybe more heat than those pads would appreciate. And, you know, there's a few spots where the solder didn't even cover the other side of the vias very well. So yeah, there's just a whole pile of compounding things going on here. Yep, bare naked metal right there. Exactly. There was one of them you could see it did flow through. These three here had a little bit. You can almost see the solder blob coming through. Oh wait, I'm pointing on the wrong screen. You can almost see the solder blob coming through right there a little bit. Yeah, you can kind of see it on these 3 pins here a little bit. But yeah, I don't know if they could put enough heat on that for long enough to get it to wick all the way through without damaging the board. And you can see these 2 here. That one is not coming through, but you can just barely see it down in the hole there a little ways. Yeah. All right, well, I think at this point, I should probably go get some food, and we might call that a stream. I think we accomplished our mission. Not design flaw, but the way they assembled it is the issue. They got the design apparently fine, but they couldn't figure out how to put it together properly. Yeah, anyways. All right, see you later, everyone. Thanks for hanging out. Must eat food. That would make the stream be done. There we go. Look at the waterfall.
Robust.